Okay, the binomial expansion, super quick review. If you need more than this, you need to go back to the old teaching videos and make sure you've understood this. Biggest mistake that people make with the binomial expansion in the exam when they're panicking and rushing is that if there is a minus sign somewhere in this thing, they're going to lose it. And we really, really, really don't want that to be you. So make sure when you're doing this, you are absolutely fixated on those minus signs. Okay, so the idea with this is that one of your two terms in your binomial, so your two-termed expansion, has all of the power at the beginning and loses it by increments to the other thing. So in our first term, we're going to have the 2x having all of the power and the minus 3 having none of it. In our second term, our 2x is going to have 3 and our minus 3 term, notice it's minus 3, has 1. And we go all the way down until the minus 3 has all of the powers. This is not it, obviously. We know that these terms appear with different frequency, and you know that from having expanded a great number of, hopefully a great number of quadratics and cubics and all that kind of stuff. So we need to calculate as well the coefficient that sits out the front of each of these terms. And we do that using the Pascal's triangle or using your choice button on your calculator. So super quick run through. If you are in your run menu on a large calculator, so CG20 or CG50, you go to option and then scroll over till I haven't done this in a while. So you press F6 and you get another option. You hit probability, which was F3. And then you've got an NCR button. That is going to be your button. So here we're going to have 4 choose 0, which is 1. The next one we're going to have 4 choose 1, which is 4. The next one 4 choose 2, which is 6. 4 choose 3 is 1, and 4 choose 3 is 4, and 4 choose 4 is 1. And then we're going to add all of these terms in up together. So our first one then will be 16x to the power of 4, and that's going to be it because we've got 1 times 1 with that. And then we're going to have 32x cubed times by a minus 3. So that's going to actually be minus, and 32 times 3 is 96. Go me, I can still do maths. Then we've got our 4 choose 2, which is 6, timesing that by 4, which is the 2x squared, and then timesing that by the 9, which is minus 3 squared, and that gives us plus 216x squared. And we'd keep going on. One of the biggest problems I find, other than the minus sign being forgotten, is that people try and add these terms. So you'd end up with 4 choose 0, add 2x to the 4. People know they need to add somewhere, but not sure where. All of these terms get multiplied as they are, and then you add the individual terms at the end. So make sure you keep that order straight in your head. You will win at the game we call your Maths A-level if you just check stuff. I promise you, it's going to make your life so much easier. And every year I'm convinced that students think if I start checking on the day of the exam I'll be okay. No, you won't. You need to check from the moment you learn a technique so that it becomes quick and second nature. To check these kinds of things, pick a small value of x. So make x equal 0.01 and substitute that into your question and also the answer you think you've got. Now, if you haven't done the complete expansion, so you've only gone up to, say, the x squared term, you won't have an exact value matching up in those two substitutions, but it'll be pretty close. My piece of advice is when you get into your exam and your calculator is in exam mode, store x equals 0.01 as a test value. I store it under t, so it's always there for me when I want it. And then I can chuck literally that expression into the calculator. So 2 times 0.01 or if you've got it stored, 2 times by your stored value, minus 3, all to the power of 4, and that gives me an answer of 78.8615, and so on and so forth. And by substituting in that same value of 0.01 into the expansion, I'll get the same answer. And that's great. That's exactly what I want. If I've got the same answer, I haven't made any mistakes anywhere.